Hi everyone, I'm Boyoung Kim from Virginia. Today I'm going to talk you guys about the history of Kubernetes.
A long time ago, in a far, far away, where there was Google, Larry Page and Sergey Brin, two PhD students at Stanford University, created a search engine that used to link to judge the importance of individual pages on the World Wide Web in their dormitory room. Based on this basic search engine, today's Google was founded on September 1st, 1998. Since then, Google's business has continued to grow. Clearly, it's not a video about Google, so the story of Google's evolution will end here. Anyway, people loved Google's search engine, and as you already know, word travels fast. Lots of people from various countries started using Google as their primary search engine. Now, the company needed a huge infrastructure to make this engine available to all these people. Because of these needs, Google had to invest lots of money to expand their business. And one of the ultimate solutions was the container technology. So what was the main strength of container technology? Is it different from legacy VM? VMs include the guest operating system along with all the codes for their implications and application dependencies that formerly ran on a single server or from a server pool. In contrast, containers share the host OS and include only the application and their dependencies. The size of container images is generally measured in megabytes. Every container running on a single server shares the same underlying OS. Containers thus can spin up in milliseconds and are more efficient for ephemeral use cases where instances must be spun up and down with changes in demand. With this point of view, Docker started a simple idea in 2013. Most of the apps do not always need a complete OS with all of their services. Docker leveraged this idea and started a Docker engine as an open source in 2013. Google relied on containers independently of Docker. To orchestrate containers, Google started a new project, the Borg project. I used the Star Wars reference from the second slide, but I think Google employees liked Star Trek more. With similar concept in Star Trek, it is collective systems that are connected to other Borgs. The attractive point for the public was the idea of making Borg available as an open source. Finally, Kubernetes was born. If you want to know about this story, click there. Previous Virginia's video by Kisong will tell you. There are so many advantages of using Kubernetes that I cannot list them all. I'll just name few. Automate manual process, run everywhere, horizontal scaling and rollout rollback, container balancing desired state, orchestrate easily, additional services, finally save money. If you were an IT operator, these features would allow you to spend less work and probably you had nice evenings. Let's get back to the burn of Kubernetes. What was Kubernetes like when it was a baby? What features did it have? Kubernetes was born on July 21st, 2014. Now that it's over 6 years old, it's no longer a baby, but a child. From this table, it is conjectured that Kubernetes must have a turbulent childhood. Version 1.1, so many improvements and HPA and HTTP load balancing beta. Version 1.3, autoscale. Version 1.5, CLI and stateful set. RBAC finally G8, CSI G8, and so many changes reflected. Then finally, the biggest news to all users, the era of Docker Swarm deprecation. If you search this keyword on Google, as you can see in the picture on the right, there are lots of search results. Kubernetes official document announced this release as the latest release. You can search it on kubernetes.io. Spoiler alert, Docker images can be used as before. It can be confusing because of the term Docker, but it does not refer to a Docker image, but to a container runtime built into Docker called Docker Swarm. One of the most painful things for web developer is you must support Internet Explorer. Docker Swarm has become like Internet Explorer in Kubernetes ecosystem, and Kubernetes has decided to deprecate it. Truly, Kubernetes is a fantastic platform, but it has the disadvantage that it is difficult to migrate from other platforms, and it has huge learning curve. There are many competitors who have overcome these shortcomings, representably like below. First, CaaS, which means container as a service. With this, you can manage all the containers at scale without complex orchestration. Second, managed Kubernetes service. This lets you run managed, hosted Kubernetes cluster. It removed operational human cost of data operations like deploying, upgrading, maintaining Kubernetes. PaaS, abbreviation of the platform as a service, offers a complete platform with simpler operations and built-in capabilities like monitoring, observability, security, and networking. Last, lightweight container orchestrator. For example, Docker Swarm and Nomad are competitors, but they are less famous than Kubernetes. Let's talk about serverless. It is a technology that allows you to provide service by writing only functions without running containers for separate applications in Kubernetes. Public cloud providers like AWS, GCP, Azure are already providing serverless function as service. First, Azure Functions. Second, AWS Lambda. And there's also Google Cloud Functions. Since the serverless function does not need to run the underlying infrastructure all the time, it has the effect of significantly reducing infrastructure cost. That is, the method that uses resources only when a function is executed. Various open sources to support such serverless are also developing the Kubernetes ecosystem, and representative open sources are as follows. OpenPath, Kubernetes, Vision, OpenWhisk, and Knative. By the way, serverless and Kubernetes are not a zero-sum game. They can be grown together without serious competing. Serverless can be the result of the abstraction of applications. However, not all applications can be delivered in the same way. Sometimes application needs requirements of orchestration and management via container because it is mature technology, so it gives you more benefits like capabilities of monitoring, logging, load balancing. Now let's take a look at the future of Kubernetes from a developer's point of view. Generally, the Kubernetes we know today will disappear. This is not to say that we will not have Kubernetes in our stack. The majority of the traditional Kubernetes resources may have better alternatives for developers. Using alternatives will improve how we develop and operate cloud-native applications in the years to come. After all, Kubernetes is a platform for building platforms. It is not the end game. So take a look at the 4 possible improvements vectored below. Workload definition. Managing workloads with deployments and HPAs works well if our application sees slowly varying capacity demands. However, with the shift toward microservices, event-driven architectures, and functions which handle one or possibly a few events or requests and then terminate, this form of workload management is far from ideal. The Kubernetes event-driven autoscaler, KEDA, can improve the scaling behavior of microservices and best changing workloads such as functions. Also, Knative is a platform that builds on top of Kubernetes and takes an opinionated view on workload management through a Knative service research. There's a few points to improve with the English research. The primary problem is that it only lets us manage the very basics of HTTP traffic routing. The need for more control and programmability of the Kubernetes network can be seen in the rise of service meshes. They divide the English research into multiple resources for a better separation of duties and provide additional functionality in routing, observability, security, and fault tolerance. Stories. From a high-level perspective, a problem with persistent volume is that they combine the primary concern of our application with a storage concern, which is not an ideal cloud-native design pattern. A dramatic improvement in data security is possible when we consider storage as network attached. For example, consider object storage through REST APIs. And with serverless workload pattern, we should expect more dynamic and shorter lead workloads. For example, serverless functions handling one event per pod. Security. Kubernetes provides a secret research to specify static secrets such as API keys, passwords, etc. Explicit secrets encoded in secret resources can be leaked and are troublesome to rotate and revoke. That's why instead of things you know, like passwords, API keys, application authentication and authorization should be based on who we are. Developers can base authentication and authorization on OIDC token.
The journey into Kubernetes history is finally over. Did you have fun? I hope this helped you understand Kubernetes better. Please like and subscribe to my channel and press the bell icon if you don't want to miss new video. Thank you.